Hello, dear student. How are you? I hope you are all will be fine. I'm also fine. Thanks you. Welcome to our channel. Let's start today's topic. Today is lecture number 5 of nucleophilic substitution reaction. And today lecture we will be study about in previous last 2 or 3 lecture we studied about the reactivity of the nucleophile in Sn2 reaction, but in today lecture we will be study the reactivity of the substrate in Sn2 reaction. Today we will study the reactivity of the substrate in Sn2 reaction. In Sn2 reaction the substrate has also very important effects that has also very great effect in Sn2 reaction. So what was these effect? What is these effects? Let's start today's topic. Yeah, this is substrate. This is one substrate. Substrate are those compounds on which nucleophile attack. This is substrate. This is one substrate. If any nucleophile attack on this carbon and this electrophilic carbon, this is the substrate. This is the substrate. So if there is a one good leaving group attached with the substrate which is very good leaving group, if let's suppose this is a good leaving group, if this is good leaving group, then it will be affect that it will be proceed the Sn2 reaction very rapidly, because whereas the nucleophile attack on this carbon, directly the leaving group will be leaved. But if this leaving group is not a good leaving group, this is poor leaving group, so it will be affect, it will be cause this here, this group will be cause reactivity. So this reactivity, due to this reactivity, it cannot be show a good leaving group. That's why substrate is also a very great effect in Sn2 reaction. It is also very great effect. So let's start. A leaving group. First of all, we will be study about what is that how the leaving group affect the substrate. Are you ready? Okay, let's start. So first of all, we will be study about the leaving group effects on the substrate. Leaving group. Leaving group that effect on the substrate. That effect on the substrate. Yeah. Today we will be study this. The living group has This living group has serves two basic purpose in Sn2 reaction. This living group has two basic purpose in Sn2 reaction. First of all, the first purpose of the good living group, the first purpose of living group is polarize the CX bond. X is the living group while C is the electrophile. It polarize the um, it polarize this carbon and leaving group bond, because if when the uh, leaving group is more electronegative, as the leaving group is more electronegative, it will be effect to attract the bond pair of electron toward themselves. So that's why the carbon will be getting partial positive charge, and the halide ion or the leaving group will be get partial negative charge. Due to by this is the first purpose of leaving group, because due to leaving group this bond become polarized. When this bond become polarized, the nucleophile can attack on this carbon or on this atom that are partially positive charge, that get partial positive charge, that which act as a electrophile. So the nucleophile can be attacked on this carbon easily. So the first purpose of leaving group is it polarize the CX bond, while the second purpose of the leaving group is it leaves a pair of electrons that once bonded it to the electrophilic carbon atom. It leaves, it is the second purpose, it leaves with the pair of electrons. This is the second pair, because as the nucleophile has also the property that it can donate it can donate lone pair of electrons. So let's suppose this is the nucleophile, this is the substrate, this is the substrate. this is nucleophile. When this nucleophile attack on this carbon which is partial positive charge and halide ion are then leaving group which is partial negative charge due to electronegativity difference. When as the nucleophile attack on this carbon, it means that this nucleophile donate the lone pair of electron to this carbon, but we know that that carbon has the covalency of carbon are completed because it has already four bonded, so that's why at to attack or to bond with nucleophile to bond with nucleophile the carbon that bonded with nucleophile, it should necessary it should need for carbon that it will be lost one electron pair. That is, so as the electron pair lost easily, that will be called a good substrate. So the nucleophile also act as the leaving group also act as a leave with a pair of electrons. So this bond we know that this bond contain two lone pair, two electrons of. So these electrons will be attracted by this leaving group because of more electronegative. So as the nucleophile attack on this lone pair or this bond pair, this bond pair electron will be leave with the leaving group and the reaction become it will be nucleophile plus the the this electron the electron pair that are the bond pair of electrons that will be leave with the leaving groups. Yeah, and become negative charge, it will become anion. As that clear, this is the main two purpose of leaving groups, and the leaving group will be those leaving group will be a good leaving group which follow the following condition. Let's start the condition. What will be the condition? What is the condition? Yeah, here condition for a good leaving group, condition for a good leaving group. Conditions for a good leaving group. What is the condition? The first condition, electrons withdrawing to polarize the carbon atom. Electrons withdrawing, I will explain this with very detail as I write. Electron withdrawing to polarize the carbon atom, to polarize the carbon atom. I will explain this later. Let's first I write you this condition. The first condition will be electron withdrawing to polarize the bond. It means this is the first condition for leaving group. The leaving group, those leaving group will be a good leaving group that can easily electron withdraw, that can strongly withdraw the electrons of the bonding pair of electrons. If these withdraw the bonding, if this halide ion or this leaving group if this leaving group withdraws strongly withdrawing the electrons, that will become that will lead to polarize more the carbon and X bond or more the carbon positive charge. It will provide positive charge on carbon atom, means that it will make the carbon that to ready for attacking of nucleophile, means the carbon will become electrophile. So those leaving group will be good leaving group that strongly withdraw the electron of the bond pair. This is the first condition. The second condition is the leaving group will be stable leaving group. Once it has left, stable leaving group generate once the reaction, or you can say once it has left. The stable leaving group generate once it has left. After the reaction, like in this reaction, this leaving group will be, if this leaving group is more stable in this reaction, if the product this anion is stable anion, so that's why the reaction this leaving group will be called that is good leaving group, because as As they leave easily, the nucleophile will be attack on this carbon very good. So that's why that is the stable leaving group generate once it has left, it also effect on good leaving group. The third condition for the good leaving group is polarized to stable the transition state. It has also the property of good leaving group. Polarized to stable the transition state. The transition state. It has also the leaving group, those leaving group will be good leaving group, those leaving group will be good leaving group that can polarize the bond between carbon and leaving group. But in case of transition state, as the transition state established, let's suppose this is nucleophile, this is substrate, and this is leaving group. Yeah, it means that this nucleophile partially donate, this bond partially formed while this bond partially break. The bond between halide ion or the bond between leaving group and carbon, it will partially break, while the bond between nucleophile and the carbon, it will partially formed. So this means that this nucleophile donate a partial lone pair or partially electron pair to this carbon. It also means that those leaving group will be good leaving group that can easily withdraw the electrons from this carbon. It means that the good leaving group will be those good leaving group that the transition state becomes stable due to this, because as they strongly withdraw the electron, it will affect to polarize the carbon, it will affect that nucleophile will, it will affect that the carbon will be getting more partial positive charge. As the carbon become more partial positive charge, it will lead to gain the electrons from the nucleophile and produce the nucleophile carbon bond and break the carbon and leaving group bond. So this is also the great effect, it has also great effect on the leaving group. So let's explain one by one. Yeah, you can also take screenshot or you can rewind the video. I am just clearing the board. As I told you, the first condition in which the leaving group must be strongly electron withdrawing group. When it is when it is strong electron withdrawing group, it will be called a good nucleophile. It will be called a good leaving group. Sorry. So let's suppose when this is case, nucleophile that attack on one carbon. Let's suppose here is OH group attach. If this nucleophile attack on this carbon, or you can say, if let's suppose there is a here is electron withdrawing group attached or any leaving group attached, that is leaving group, this is leaving group. Yeah, as the nucleophile attack on this carbon, why this nucleophile attack on this carbon, not on other atom? Because it is electronegative element, it electron withdraw from this bond. As the electron withdraw, it will become polarized, this bond become polarized, and carbon get partial positive charge, because leaving group take withdraw electron from this bond. That's why leaving group gain partial negative charge and at carbon partial positive. So there is deficiency of electron occur, electron density become decreases. That's why nucleophile can attack on this carbon that act as an electrophile. So after the transition state become established, in which transition state can be written as like that. Yeah, can be written as like that. Here in this case, the nucleophile is partially donate lone pair of electron to carbon. This means that due to the donating of electron, this means that the carbon become partial negative charge, because partial electron donate toward carbon. So if the leaving group is a good leaving group, if the leaving group is strong electron withdrawing groups, it means that it will be stabilize this negative charge, it will be stabilize this electrophilic carbon that become negative charge. So if this leaving group is not enough electronegative, if this is not enough electronegative that can polarize, that can decrease the negativity on this carbon, that will be called a poor leaving group. So if this group is strongly electron withdrawing group, so it means that it will withdraw the electron and become itself, it become more electronegative, while the carbon become the negative charge, the negativity on the carbon will become decreased. It means that the transition state becomes stable. So as I already told you in third statement, that the third condition for a good living group, that those living group will be good living group, that creates more stability, that give more stability to the transition state. So if there is strong electron withdrawing group, it will increase the stability of the transition state. As the stability increases, this means that an energy diagram, it will become like that. The energy barrier, let's suppose this is the diagram for, this is energy, this is energy, this is reaction direction, this is reaction direction in forward direction. So this is the diagram for those compound in which strong leaving group attach, in which uh, in which strong leaving group attach, strong electron withdrawing group attach, electron withdrawing group attach. When strong electron group attach, the energy barrier will be that, this will be the energy barrier, this will be the activation energy. But in case of when there is when this is strong electron withdrawing group, but in case of weak electron withdrawing group, what will be the situation? In case of weak electron withdrawing groups, this is energy. Let's suppose this is the start of the energy, that is the initial state of the reaction. So the reaction will be like that. When in this case the transition, the weak electron withdrawing group, when weak electron withdrawing group are take instead of this leaving group, when there is weak electron withdrawing group or weak leaving groups, so in this case the activation energy will be more activation energy will be very greater, because this energy lead to get instability. Instability means the energy will be increased. Why the energy increases? The energy increases because in this case the nucleophile is the strong electron withdrawing group attached, it stabilize the negative charge on this carbon, which was produced due to the donating of electron by nucleophile to this carbon. By this a carbon get negative charge, so the leaving group withdraw the electron and stabilize the negative charge on this carbon. So if this is good leaving group, means this is good with electron withdrawing group, it become more stabilized the transition state. When they more stabilize, it means that the energy barrier, it become less energy, the activation energy will be very less. Activation energy or those energy, that is those minimum energy that is required to initiate or to start the reaction. So the initiation energy will be very less. But in case of when this is strong, when this is weak electron withdrawing group, when this is weak electron withdrawing group, it have not enough capability to polarize or to stable the negative charge or to stable the transition status. So that's why the activation energy in this case will be very high, means the reaction will be not rapidly, the reaction will be slow reaction. In this case the reaction will be slow reaction, while in this case where the activation energy is weak, the reaction will be fast reaction. So these all are about the reaction, the leaving group effect on the leaving group, how the leaving group effect on the substrate. Yeah, I hope this point will be cleared. Let's suppose this is the first point and third condition that I told you. Let to start the second condition. As I told you that the leaving group must be stable. Leaving group must be stable. Leaving group, leaving group must be stable. Group must be stable once it has left. What this mean? What this sentence mean? Leaving group must be stable. Leaving group must be stable once it has left. This means as in the reaction direction. Let I explain you by example. Let's suppose this is one leaving group called X. Let's suppose this is one leaving group called Y. Let's suppose X is strong leaving group. X is strong leaving groups. X is stable leaving groups. X is stable than Y. When they generate, when as the nucleophile attack in both cases, when they attack, so the X will be stable than Y. It means that nucleophile C plus X negative, nucleophile C plus Y negative. So in this case the X, let's suppose the X ion is stable than Y ion. So which reaction will be favored? The first reaction will be mostly favored, because in this reaction the leaving group, as the leaving group leave the compound, as the nucleophile attack on the center atom on the substrate, and the leaving group leave. So if this leaving group are stable, it means that this stable group show less reactivity, that shows stability. Stability means that it show less reactivity, it show reactionless. But in this case, when there is Y negative, when this Y negative, this leaving group, let's suppose this is unstable, as compared to the halide, as compared to the X ion. If this is unstable, it means that instability means that show reactivity, it show reactivity. When they show reactivity, it means that it will again a reaction on this carbon. So the reaction will be not be completely favored in forward direction, because the Y negative is not enough stable when they are alone, but they will become stable when they are attached with this carbon. So that's why they cannot be leave the system easily, as compared to the X, that they can it can easily left the group, because by itself, when it is alone, it become more stable, it show less reaction. So that's why, that means that the negative charge, those leaving group will be good leaving group, those leaving group will be show good leaving group, it will be show good Sn2 reaction, which has which is stable after the reaction. So what is the condition for stability for the good nucleophile, for leaving the nucleophile? What is the condition? The condition, there is only one condition. The condition is a good leaving group should be a weak base. Good leaving group should be a weak base. Should be a weak base. Yeah, what this mean? There is two types of leaving groups. One is weak base and one is strong base. I think I already told you in second lecture. not in second lecture but in first lecture I already explained you this point. Good leaving groups should be those which are weak base. Weak base it is weak base are those base weak base are those base that are the conjugate base of strong acid. Weak base is the conjugate as the base of strong conjugate acid. Strong conjugate acid generate weak base. Let's, for example, HCl, HBr, HI, and these all are strong acids. So their base will be, their conjugate base will be weak base. Their chlorine, bromine, iodine, these all are will be weak conjugate base. So when as the base are weak base, it will be show the good leaving group. It will have the property that it can become easily left in the Sn2 reaction, in the substitution reaction. So it will be easily substituted when there is a good leaving group. So for example, there is two reaction in which, let's suppose, instead of x there is chlorine attached, while in another instead of y there is OH group attached. We know that OH is not enough. OH is strong base. OH is strong base, not weak base. OH is very strong base, while chlorine is weak base. In case of H2O, when they generate H plus plus OH negative, this hydroxyl ion again attack on this hydrogen and this proton. The hydroxyl ion become protonated very easily, very rapidly. So it will become again form produced. That's why it show more basicity. It means that they will give more. They will give show to donate easily the electron pair, to show easily donate the lone pair. But in chlorine, in HCl, when they dissolve in, they dissociate into H plus plus Cl negative. In this case, in this solution, the chlorine is not enough strong that they attack on this proton rapidly as compared to in this reaction in hydroxyl ion, is hydroxyl ion will very fastly reaction on this. So that's why chlorine is weak base while hydroxyl ion is strong base. So in this case, the nucleophile on which carbon and which they attack on the substrate in which chlorine is attached. So chlorine is good leaving groups because it is weaker base. But in this case, nucleophile, that is same nucleophile, same substrate, only leaving group are different, which is OH. When in this case nucleophile attack on this carbon, the OH group will become OH group will not be easily left the group because OH has a strong base. Strong base mean that it can donate easily electron pair. So in this case, the hydroxyl ion, the electron pair in this bond, that will be that will be not attractive, that will be not near towards hydroxyl ion towards leaving groups, because this show more basicity, and basicity means that they will donate the electron pair. So it means that they show that they donate the electron pair, this pair, to this carbon, which means that it makes strong bond between this leaving group and carbon. But in case of chlorine, which is weak base, weak base means that weak base are those bases that cannot show easily, that cannot donate easily lone pair of electrons. So that means that this electron pair will be not towards carbon, but it will be towards chlorine. It will due to the electronegativity of chlorine, it withdraw these electrons, withdraw the chlorine, so the carbon will become more polarized. That's why weak the stable, weak the base, weak is the base, weak the base show strong leaving group, while strong base show weak leaving groups. These are the general features of the leaving group in case of substitution reaction, when they are when the substrate are attacked by the any nucleophile, in the reaction, the leaving group must be left after the formation of the bond between nucleophile and the electrophile. So the leaving group must be left. So these are the conditions, these are the something about I am talking about that those leaving group will be good leaving group that have that are strong, that are weak base, and those leaving group will be strong leaving groups that have high the power of electron withdrawing group, means more electronegative, while those leaving group will be good leaving groups that can give stability to the transition state. I hope you are will be cleared. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp Gmail that I drop and description box, you can get from there. And also please subscribe my channel if you like the lecture. Please, it make me feel happy that my students are supporting me. Okay, thank you, very best of luck my dear student, very best of luck.